Let's say we have a ramp or an incline with the angle of inclination equal to 30 degrees. And we got an object with a mass of, let's say, m sitting on top of this ramp. This object, if there is negligent gravity or which is close to zero, it starts to slide down immediately as we put it on the ramp. And what is pulling it down is the force of gravity. The force of gravity, this is basically our ground. The force of gravity is always perpendicular to our ground. So here, the force of gravity will be pointing down perpendicular to our ground level, which is here. Now the force, and let's call this one Fg, force of gravity. Now the force that is actually pulling the object down the ramp is a component of that force of gravity. And all we need to do here is try to find the component which is pulling it down. From vectors and from trigonometry, we know that how to find the components of this vector. So basically, we need to draw the triangle, the right triangle, and get the x component, the y component, and this is going to be our hypotenuse. Now, how do we do it here? So from here, if we go perpendicular to a ramp, that is going to be FG y. That is the y component of our triangle. And then the component that is pulling the object is fg of x, the x component, which is pulling it down. And if we bring that one down here, we make a complete triangle. Let me draw it down here. So that is the fg, and then we have the x, and then we have the y component. So that is fgy, and this one is fgx. So we have the x component, the y component, the y, the x component here, and that is the fg going down as the force of gravity. So all we need to do is find one of these two angles, and then we can say what is the value of fgx and what is the value of fgy. Now let's go back to this figure and find out what is these two angles equal to. So if that angle is 30, from here, that is the right angle, which is the 90 degrees. And this angle is going to be 90 minus that, which gives us 60 degrees. Now, going back to trigonometry, if we extend this line going down here, we have another triangle inside the big triangle that we have. And since they have two congruent angles, 90 degree here, 30 degrees, 30 degree, and 90 degree, so these we can use the angles to find it. So this angle is 60, that angle is 30. And if we extend this one down, that angle is 90. And we also know that then this angle is going to be 60, which two parallel lines, a line going through them, these two angles are congruent. So that angle inside our triangle, this top angle, is this one, which is 60 on the outer, so the inner will be equal to 30 degrees. So this angle is 30 degrees, which is congruent to that angle. Now from here, we can find fgy and fgx to further explain what happens, the speed and the acceleration of the object going down. Now, in order to find these, SOHCAHTOA. So we have sine of that angle is equal to opposite over hypotenuse. Let's write it down here. So sine of theta, which our theta here is equal to 30 degrees. Sine of theta is opposite over hypotenuse, right? So over here, if gx is opposite, if gx, and the hypotenuse is basically fg. Now, if we are looking for fgx, so fgx, from that we will have fg multiplied by sine. So fgx is equal to fg sine of theta. Now, fgy is going to be adjacent over hypotenuse. So it will give us fgy will give us fg cosine of theta. So now that we know what the two components are, we can say on this ramp or on this incline, as soon as we, assuming that there is almost zero friction between the surface of the incline and the object, we know sigma f is equal to ma. So the force, there is only one force pulling the object down, and that's fgx. So fgx is equal to the mass times acceleration. So the acceleration of that object is going to be equal to fgx over m. And that's the case if we only have one force, and that's the force of gravity pulling it down. Now, what if we have also force of friction and it's not equal to all zero or very close to zero? If we have a larger force of friction here, what happens? Force of friction is going to be opposing the direction of the movement. So the object tends to go down the incline. So the force of friction is going to be in the opposite direction. So we will have F of friction in the opposite direction. So the sum of the forces is going to be sum of these two forces. Now, what is force of friction equal to? So F of F, force of friction, is equal to mu times n. Now, first, let's say what is mu? Mu is a constant, and it depends on the surface that we have here. So that mu is coefficient of friction, and n is equal to the normal force perpendicular to the surface. Now here the normal force perpendicular, so if I draw it up, that is our n. That is equal to the force that is pulling it down, and that is Fgy. So F of force of friction will be equal to the coefficient of the friction multiplied by Fgy, and mu should be given to us, or we are looking for that. So that's the equation of the force of friction over here on this ramp solving. So, and then we plug in Fgy from this one, and then we get the force of friction. Now let's go ahead and look at one example and see how we can use all of these to solve for our example. Okay, now let's say we have a ramp with an angle 30 degrees and the mass is equal to 10 kilogram. And then we are also given that mu is equal to 0.5, 0.5. And then we are asked for acceleration of the object going down the ramp. So the very first thing that we need to do is find FGX and FGY. So these the two components of the force of gravity. So if we draw the force of gravity, let's call that one Fg. Then we have FGY and we have FGX. And the FGX is basically the one that is pulling it down. And that is the angle. So we said that that angle is congruent to that, which is 30 degrees. So FGX is the opposite. So FGX is equal to FG sine of theta, which is 30 degrees. FGY is Fg cosine of theta and 30 degrees. Now, what is Fg? Well, Fg is equal to basically mass times gravity. Now, we can go ahead, plug in here the values and solve for it. So mg, if we do that, is 10 times, we get the gravity equal to 10 for easier to get the answer. So 10 multiplied by 10 is equal to 100 Newton. So we plug in Fg 100, and then sine of 30 is equal to 1 over 2. So the answer will be equal to 50 newtons for Fg of x. Now, the same way, 100. Now, cosine of 30 is equal to root 3 over 2. So it will be equal to 50 root 3 newtons. And so far, root 3 is good. We could keep it, or we could plug it into the calculator and get the exact value of the FGY. But this is good enough for us right now. Now, if you want to find the acceleration, we say that sigma F, sum of all forces, is equal to mass times acceleration. Sum of all forces, how many forces do we have? We have the force of gravity pulling it down, which is the x component of Fg, which we found. Now, is there any other forces? We know that there is friction. So that friction is opposing F of F. Now we need to find what is force of friction. So F of F, force of friction, is equal to mu times N, normal force. Now we are given a mu, we need to find normal force. Normal force is perpendicular to the surface where the object is sitting, and that one is equal to the opposing force, which is Fgy. So our normal force N is basically equal to Fgy. So if we plug in 0.5 multiplied by 50 root 3, what we get, F of force of friction, will be equal to basically 25 root 3 Newton. So we found force of friction, we found the force of gravity pulling it down as this one. Now we need to add these two together and get the summation of the forces. But one thing that we need to be careful here is that that force is going down in the direction of the movement, so it's positive. And that force, the force of friction, is in the opposite direction. These are all vectors, so the direction matters. So that would be the negative direction, so it will give us a negative value for the force of friction. So we write 50 for the force of gravity minus 25 root 3 for the force of friction, and that is the sum of the forces that we have. Then we have m, which is 10 multiplied by acceleration, and that's what we are looking for. So we divide both sides by 10 to find the acceleration. That cancels out. Now we need to find the exact value of that root value divided by 10, and then we have our acceleration. 25 root 3 is equal to 25 multiplied by root 3 is close to 1.7. So if we multiply it, we get all 43, close to 43, a little bit more than 43. But let's say 50 minus 43 divided by 10 is equal to A. So 7 divided by 10, so A is equal to zero point 0.7 meter per second squared. And that's the acceleration of that 10 kilogram going down the ramp with the inclination of 30 degrees.